Okay, hello Algebra 3-4. So I'm gonna make a video and then I'll also have the PDF, so you have both. And this is what we did today in class on the 14th. And then for other periods, it'll be the 15th or 5. And so we talked about the goal. So some students in class said like to get X or isolate variable. That's true. And then we talked about in words how to solve this equation. And there was some variance between class periods, which is cool. And so mostly people said subtract 3 from both sides. And then if we went that route, so that was second period, we would have to multiply by -1. So that was like step 1, step 2. Multiply both sides by -1. So in second period we had 2 steps. In first period we had 3 steps because we actually added the x over, so it was already positive. Either way, there's at least 2 steps. So with the other equation, so we called this like 1 and 2, we were able to just subtract 3 from both sides and be done. So then a lot of us said that we would like prefer this. Because there was less steps or it was easier. I don't remember the exact verbiage, but just that like in general, that's a nicer equation to solve. The other thing that we noted is that these are the same. These two, I'm going to shorthand this, equations are the same except for what? Except for the sign, which makes a huge difference, right? So it's the difference between something that we would prefer to solve, right, and something that maybe is 2 or 3 steps or more tedious. So just being mindful of that. Oh, this is spelled wrong. As we continue to solve this here. Next. Okay. And then we talked about PEMDAS, which is something that you've probably seen before. So we are going to simplify. And we use PEMDAS for simplifying. And we're gonna simplify all year. So we'll be using PEMDAS a lot. And so I'm gonna rewrite it. I'll do it here. And then I'll just put a box. So again, we did this in class. If you didn't take notes, here they are. I'm going to change my color. So different classes talked about it differently, but most of you said to distribute the 4 and then sort of like deal with this. That's still times, and then like as a whole, right? Parentheses. So let's go ahead and do that. It's -4, so it becomes -12x. Negative times negative is positive. Negative times negative is positive. 12. Okay, and this was 9 times -2 is -18. And so here, my next step is to combine like terms. And so these go together and these go together. So I have -9x. Oh dear, -6. So when you are simplifying, you end up with an expression. Or sometimes it's just like one term. An expression. Okay, so for the other part, we're going to reverse PEMDAS. And we call it SADMAP. So this is Mr. Maurer, if you know him. He's lovely. Maybe you had him for Algebra 1, 2. So now we're going to use this for solving. Solving is like the reverse PEMDAS. So I'm going to put it over here. So it's the same expression, but now it's set equal, so it's an equation, to a number. But everything is the same otherwise. Okay, so basically before I can start solving, I have to simplify. So I'm going to say like simplify before solving. Okay, and luckily it's the same, so I kind of already know the next line of this. Oh, what was that? -18. Okay, so same thing, I'm thinking about SADMAP, like can I like add or subtract? I'm like, well wait, it's not simplified, so I still need to like simplify. So again, these go together, so I should have, yeah, my like purple thing, right? I should have this. Because those, okay. I know in class I dropped one of the 18, so I didn't want to do that. Okay, so now I can solve. So now I use SADMAP. And you don't have to call it SADMAP, you can just call it solving, but it's the idea is there. So I'm going to think to myself, okay, can I add or subtract? Yes. So I'm going to add 6 to both sides. Okay, so here I want to sort of erase that a little bit. Okay, and then I'm thinking, okay, I did that. Is there division or multiplication? Yes, I have -9 times x. So to undo multiplication, we'll look at this on the next page, I think. We're going to divide. So I'm going to divide by -9, divide by the coefficient. And we get a fraction, which is fine. And I stop here, right, because I didn't have any exponents or parentheses in this final, like, simplified life. You can also say -11/3, but it doesn't really matter. Oof. Okay, so simplify before solving. Please. Please, please, please. Okay, so we, in some of the classes we did this. So if you have like x plus 3 equals 7, you would subtract. Here you have subtraction, so you need addition. So x minus 3, this is like our first example, you would add. Okay, so to undo multiplication, you need division. So for example, 3x equals 2, I would divide. If you have division, you need multiplication. So this is like for rationals. So if you have 1 over x equals 4, you're like, no. You would have to multiply. So then you would have 1 equals 4x. And if someone says something about cross multiplication, I'll forgive it because of our current situation, but it's just inverses. Okay. Square root looks like this. So you need a square. So for example, if I have square root of x equals 2, I would come through and I would square everything. So those are gone. So now I have x equals 4. If I had a square, and we practiced this in class today, I would do a square root. So for example, we had like x plus 3 squared equals, what's a nice number? 16. You would square root. And then this is where you have the plus or minus happen. So you have two solutions. The nth root, you're going to take the nth power, and we'll talk about this later. But so for example, if I had a cube root, I would raise it to that power. We did that a little bit in algebra 1, 2. Just a little bit. 2 cubed, or what is that? 8. So same thing, these are like inverses. Okay, so if I had, for example, x to the third power equals, what's a nice number? 3 times 3 times 3 is 27. I would take the cube root of that. And then x equals 3. Yeah, okay. So that's that. We didn't really go over those in class, but that's how those are working. Next. Okay, so I don't know why these are green. I really don't know. It's just the way it is. So what we did, I guess I'll write it in the box and then I'll rewrite it. So this is multi-step. And this is quadratic. And I know because it has that little square. This is multi-step. And this is rational because it's x in fraction. Okay, so let's do that. 6x minus 1 plus 6x equals 11. It's a little messy. So combine like terms. 12x minus 1 equals 11. And then here I would think about my sad map. My sad map. Poor PEMDAS. Being like used against themselves. Okay, so I would say, okay, do I have anything to add or subtract? Yes, I do. So I would say plus 1, 12x equals 12. Great. And then I'm like, okay, so I did that. Do I have anything here to divide or multiply? Yes. I'm going to go over here. So I'm going to say 12x equals 12. Divide both sides by the coefficient, the number in front of x. So x equals 1. So that is technically 1, 2, 3 steps. Could you do it in less? Probably, but... Oh, I wanted to do them with the right color. I didn't do that. Sorry. Okay, so the quadratic is sort of like there's nothing to simplify. Is it possible that there would be? Yeah, but not right now. Okay, so I'm going to start my sad map. So is there anything to add or subtract? Yes, there is. So I'm going to do plus 4 plus 4. Quantity x plus 3 squared equals 4. Okay, so I did that, right? Is there anything to multiply or divide? Nope, I don't have any coefficients or I don't have any fractions. Is there an exponent? Yes, there is. So I'm going to take the opposite, which is a square root. So what happens is that this pops out plus or minus 2. And we'll talk about that here in a second. So I have two options. Positive. And I have negative 2. So let's just finish this and then we talked about this in class, but we'll talk about it again. So now I reset my solving. Okay, add or subtract? Yep. So I'm going to minus 3, subtract 3 from both equations, both sides. Is that negative 1? And it's an ampersand. Negative 5. Okay, so alert, red alert. Because 2 squared equals 4 and negative 2 squared also equals 4. Also, it's a parabola. And so there's 2 spots, right? 1 and 2. There's 2 solutions. So this one would be a really good one to have on the Padlet for our solving flip book because sometimes there is one solution. I know Lily asked about that in one class. And then sometimes there's also no solution, but we'll see that at a later time. Super fun! Okay, I'm going to sort of like contain this. I'm going to try. And then that 2 kind of got cut off. Okay. Multi-step. So I'm, again, hoping multi-step feels better than the others. I would distribute. Let's distribute this. What is that? -8? 7 times 8 is my least favorite multiplication fact. And I hope that you are inspired to figure out which is your least favorite multiplication fact. I hate it. It's 56 though. Equals -8. Okay, so again, before I can solve, I have to simplify. So combining like terms, the x's, and then I guess that number has to go, but what is this? -61. That would be a good calculator question, especially if we're dealing with negatives. Okay, so now I can start solving, like moving stuff around. Could I do it in the previous step? Sure, but I have like way more parts than I need. Well, I have a factor of 3, but anyway, so subtraction and addition. Yes, I can add 8. I can add 8. Oh, I remember this problem. Oh, yes. Very lovely. Is there anything to add or divide or multiply? Yeah, we have to divide. It's okay that it equals 0. In fact, that's very convenient because it means the only solution, the only number that works is 0. I like that when that happens. Smiley face. This one is like a rare face. Okay, rational. We did this one in class. And I think we talked about doing it 2 different ways. So I think in one class we like subtracted 6x from one side and combined the fraction and then went from there. But you can multiply by x. So I want to show you that way. And I think I was like, if you're trying to be in second period, I was like, I'm feeling reckless. Like, just go for it. So you have to distribute. Oh no, that's gone. So you just have 1 equals 6 plus x. I know. Because it's this. Oops, that's not 6. Yoinks. See how confusing fractions can be. And this is gone. So then it's just 6. Can you all tell that that's an arrow? I don't think so, so I erased it. Okay. So now I'm like, great. I sort of jumped ahead and I did division and multiplication first instead of adding or subtracting. So again, just like be mindful of that. And then minus 6, -5 equals x. So that's one way. I know. The second way, let's do purple. So I'll show you how we did it in class. Okay, so what did we do? We did this. From both sides, it looks kind of funny when it's a fraction. So we had 1 divided by x minus 6 divided by x equals 1. That, yep. And then we had negative 5x, so if you combine like terms, equals 1. And then here, you'd have to multiply by x. Let's do green. So that would go bye-bye. So then we would have negative 5 equals x. Oh, end. Okay. Is one way better than the other? Not necessarily. I'm kind of a fan of this way because it sort of gets rid of my fractions right away. And I don't want to like make a mistake on this level. I don't want to like say that's 7x on accident. And so obviously you have some like, I don't know, agency while solving. There's different ways to solve. So just use what works for you. But sometimes it's nice to jump and like do the division or multiplication first. But you have to distribute and sometimes people get lost. Oh my gosh, there's more. Where there's so many. Okay, this one's not bad. So really quick. This is quadratic. Quadratic. Can you tell that we're going to focus on quadratics this year? And then this is rational. So for example, this one, I would multiply that 2x away first. Like, just get rid of it because of reasons. All right. This one's actually not that bad. I don't know why that box is highlighted. Just thank you for being here. Okay, sad map. Okay, so I can solve right away. I don't have to combine like terms, which is amazing. So let's do that. Subtract or add. Yep. Got a 3. Oh, that's 60, by the way. Okay. Listen, I know you want to take that square root, but I need you to slow down. So I just did this, right? I'm going to check if I can divide or multiply. Is there a coefficient? Yes, there is. So I'm going to divide by 7. Some people will take the square root of that right away, and you're going to run into some issues because I don't necessarily know what the square root of 7 is. It's like 2 point something. Okay, so x squared equals, I know this, 9. Here I can take my square root. So now that I'm done here, I can deal with my exponent. So then x equals plus or minus 3. Final answer. Okay, so this next problem is almost exactly the same. It's just different numbers. So you would practice this, right? Because you did this already on your own. Sad map. Add or subtract. Yep. Plus 9. Plus 9. 10x squared equals 90. And the other thing to anticipate is that you can really only, in this context, take the square root of perfect squares. And so if you're trying to take the square root of 90, like, I don't know what that is. So you would multiply or divide first, see if something goes away. It does. X squared equals 9. Huh. We've been here before. Let's go to pink. So now I can take the exponent away with the square root. So x equals plus or minus 3. And this was taken from a different activity where you work with a partner and you get the same answer. So that's how you would know you were correct. But those days are gone. All right. So part G is what we did in class. So just if you weren't there, that's what we did. If you were there, you should... Or wait, no. Did we do this in class? We did one like this in class. All right. Sad map. Add or subtract. Yep. Plus 3. Plus 3. So leave the parentheses, right? I can't deal with these parentheses until I'm ready to. Oh, 25. That's a perfect square. What a good day. So I'm going to go through. I just did add or subtract. Do I have division, multiply? Nope. Do I have an exponent? Yep. So I'm going to take the square root of this whole left side and the right side. X minus 4 equals plus or minus 5. So we're going to have 2 equals positive 5. X minus 4 equals negative 5. Only the 5 changes symbols. Don't change the 4. The 4 is living its little perfect life. Okay, so then I reset, add or subtract. Yep. Equals 9. Okay, and then plus 4, x equals negative 1. Okay, great. 2 solutions. Last one. Oh gosh, this one. Okay, let's get green. Stay positive. Okay, so fraction means division, so I'm going to multiply. So I'm going to rewrite this. 10 minus... If you wanted to turn these into decimals, that's fine. No, it's not. Never mind, because the x is in the denominator. Just kidding. There's some parameters around that. My bad. Okay. So I'm going to multiply, let's do black, everything by 2x. Everything by 2x. So here and here. Okay, so I'll show you this first step, I guess. Yeah. And then 2 times 10 is 20, minus 3 times 2, oops, that would be 6. 6. Okay, so just for the record, 2x divided by 2x is 1. So that's going to be the number 1. And then 6x divided by 2x is the number 3. So it's like these are canceling. But you still need those other terms. So there should be an x on everything for this. Just a heads up. Okay, so I have 1 minus 8x set equal to 20x minus the number 3. So notice that the terms that had, I think there's like a laser pointer. Oh my gosh, what is this? So this term had the x, but now it doesn't. So I used my x, what I multiplied by, on purpose to get rid of that x. Now the other term has it. Yeah? Okay, cool. All right, finishing up. So now I can add or subtract. I'm going to do a little bit of both, if that's okay with y'all. So then I would add 3 to both sides also. So then I would have 28x. And what would that be? 4? Yeah. Ooh. Divide. So I just did addition or subtraction, and then I'm going to divide. This is also a fraction. That's fine. Everything is fine. 4/28 or 1/7. Ura. Oops. Oh dear. Stop. Well, that's a 7. Whatever. Okay. Great. So you ended up with a fraction, which is okay because you have an x in the denominator. I don't think it's fine. Okay. So your work for week 1, like homework, is this. So contribute in the Padlet and then add questions as needed. If something's not clear, please let the person who posted it know, because that's not helpful, right? Okay, so that's my video. I hope this was helpful. There'll be a PDF and then also the video in my YouTube world. Yeah, okay, bye.